Our today's topic is factors influencing reactivity. So what are the factors that mainly influence reactivity of any compound? See, reagents are mainly reagents, we can say, reagents which have imbalance of electron density. Reagents which have imbalance of electron density actually undergoes reactions through various type of reagents which are charged. Reagents which have imbalance of electron density are attacked by reagents which are charged. Okay, attacked by reagents, other reagents which are charged. Okay, now what does this statement imbalance of electron density means? What does this statement actually mean? This means, suppose we have an atom, say for example it is A, and it is connected to another atom, say B. Now if A and B are of the same type, like carbon and hydrogen, or any other two atoms, like two oxygen atoms of similar electronegativity, like that, sulfur and phosphorus. So in that case, there will be very less amount of electron imbalance. That is, if one atom of the two is more electronegative, then it will try to draw that electron density from a sigma bond. It can be from a pi bond also, or it can be from a coordinate bond also. So the bonds may be different, but the one who is more electronegative will tend to take that electron towards itself through the single bond. This is known as electronegativity, or the elements which have higher electronegativity, which can be measured in terms of their higher effective nuclear charge. The higher the effective nuclear charge, the more electronegative the atom is. So this is how you can understand that how imbalance of charge actually happens in a molecule. Now, the first of the things that here we have to look about is polarity. Okay, polarity in a bond. What is polarity? Polarity is something which is related to its dipole moment. You can say about its dipole moment, or we can say that differentiation or uh, uh, charge separation inside a molecule. In a molecule, when two atoms of different electronegativities are connected to each other, they will show a charge separation. Okay, they will show a slight good amount of charge separation between them. So this is what polarity means. Poles, generation of poles, a positive pole and a negative pole. Generation of poles actually give rise to polarity. Poles means a positive charge and a negative charge pole. Now, here the first factor which influences influences reactivity is inductive effect. Any sort of inductive effect, we will discuss it in details about these effects. Inductive effect. Then we will go for another effect which is known as electromeric effect. Okay, electromeric effect. Electromeric effect. Okay, the third one is our resonance effect. Okay, resonance effect. Actually, resonance effect and mesomeric effect are quite similar to each other, but we will study it in different formats. Okay, mesomeric effect. Mesomeric effect. Now, the next one will be the steric effect. Okay, the steric effect. So all these effects actually influence reactivity to a much higher extent. How does they influence the reactivity? We will come to understand. Okay. Now let us start with the first point, which is inductive effect. Inductive effect.
Sir,
Yes.
inductive effect আর electromagnetic effects তুমি ক্লাসে করিয়েছিলে।
আচ্ছা, এটা হয়ে গেছে। আমি জাস্ট একটা ছোট্ট রিভিশন, মানে একটা ডেফিনিশন বলে
হ্যাঁ,
আমি এগিয়ে যাচ্ছি, ঠিক আছে? তো ক্লাসে যদি কোনো সময় কিছু অমিট হয়ে যায়, তো সেটা এখান থেকে দেখে নিতে পারবে। ওকে, so let's come with the inductive effect. This inductive effect is electron cloud in a sigma bond between two unlike atoms. Okay, electron cloud in a sigma bond, means a single bond between two unlike atoms. Okay, between two unlike atoms, we can say like this. Okay, now the electron pair forming the sigma bond is slightly displaced towards the more electronegative atom. That will give rise to a negative polarity to that atom and a slight delta plus polarity or slight positive polarity to the other atom. Suppose you have A and B that I have shown. So when this electron is move towards this, so this will generate a negative polarity and will generate a positive polarity. Delta means small amount. Okay, this is what inductive effect is actually is. So inductive effect is moved from, suppose it is a carbon chain. If it is moved from one carbon to another, it goes through a chain of 4 carbon atoms. It goes through a chain of 4 carbon atoms. It dies off after the fourth carbon atom. So this is the main uh, criteria, sorry, the main thing behind the inductive effect. Now, there are few parameters of inductive effect. The minus, if without minus I effect, we will not be able to understand any plus I effect. Okay, means without the electron withdrawing nature, we will not be able to understand any electron donating nature. So minus I affecting groups, minus I means electron withdrawing groups. The most electron withdrawing is NO2, followed by fluorine, which is an highly electronegative element. Then we will go for the COOH. Okay. Then the aldehydes and ketones, R or H, anything. Okay. Like this, it will go. Even we can also say that some of the groups like in Me3 plus, they are also more electronegative in nature than NO2. Okay. And plus I affecting groups are mainly those we call it as alkyl groups like Me3C, okay, Me2CH, like this it will go MECH2, that's means an ethyl group, and then it will come to the methyl group. Likewise, it will go. Now, these are the things. So, what are the main applications of this inductive effect? What are the main applications of this inductive effect? At first, we will know about the acid strength of any carboxylic acid. Suppose we are going to learn about the acid strength of carboxylic acid. Acid strength of carboxylic acid. Okay, so when we are talking about the acid strength of carboxylic acid, we have R C double bond O OH. Okay, now if you have this R group, it will have a positive inductive effect. So if I have CH3 group, CH3, COOH, and again another CH3, CH2, COOH, along with CH3, CH, CH3, COOH, and HCOOH. This is formic acid. So we will say the formic acid, the acidity of formic acid will be highest. pKa order will follow the same way, and also the pH order. Okay, pH order. So pH of this is the highest acidic order. Okay, so pKa order and pH order will be in reverse. Will be in reverse. Because we all know higher the pH, lower the acidity. So lower the pH or pKa, higher the acidity. Understood? So here, this is the main applications of here. Then aromatic carboxylic acid is also there, dioic acid, trioic acid. Or we can go on. Then we can
অ্যাসিড অর্ডারটা কিভাবে বুঝলাম?
acid order to bujlam. It has a hydrogen, it has a methyl group, it has an ethyl group. This is an isopropyl group. Okay. So plus I effect of H is least, then CH3, then CH3CH2, then CH3 CH3. So this group has the highest positive highest plus I effect. So as it has the highest plus I effect, so what will it do? It will donate all the electron towards this COOH group, making this COOH group electron rich. Okay, so higher, if it is more electron rich, then it will not have the tendency to take electrons from this oxygen. Okay, so here we have learned about the resonance also. Remember that if you have a structure like this, it will go like this. Understood? So when this need is over, so this H plus, removal of this H plus will be less. So acidic nature will also be less. Understood? It forms this type of structure, O minus double bond OH with a positive sign. Now oxygen with a positive sign is very unstable. So it will try to release this H as H plus and take its electron with it. Okay, take the electron from hydrogen and become neutral. So that is the agenda of the positively charged oxygen. But if the need of the carbon to take the oxygen and undergo resonance is over because of the plus I effect of the isopropyl group. Isopropyl group is giving electron with the help of plus I effect, and sufficient amount of electron is being obtained or being gathered by the carbon because of the isopropyl group. So it does not need that much of electron from oxygen now. It will say, okay, I will take when I will think of taking something. Okay, taking some electron. When I will think of taking some, I will ask for it. Okay, when I need some, I will ask for it. Likewise, it will be reluctant towards releasing its H plus, releasing its H plus and showing its acidity. That is why this has the least acidic, followed by this, and formic acid has the highest acidity because there is no such plus I effect of the hydrogen. Okay, so hydrogen cannot give any electron. It will give some electron, but not much to satisfy the need of carbon of the COH group. That is why the resonance will be good in formic acid of this carboxylate part, and thus release of H plus will also be very good. Okay, understood? Am I clear or should I explain it once?
Yes, sir.
Welcome. Now, next part we have already discussed about the electromagnetic effect. It is nothing but the separation of charges through the bond. Okay, another thing about the inductive effect is that we can also judge about the basic nature, like basic nature of amines. Okay, one of the important aspects of amines is the basic nature of amines that can also be understood with the help of this plus I effect. Okay, basic nature of amines. Amines means they are NH, means derivatives of ammonium. Okay, alkyl derivatives of ammonium. You are removing one hydrogen and replacing it with alkyl group. Okay, these are ammonia. Ammonia, 1 degree amine, 2 degree amine, and 3 degree amine, trialkyl amine. Okay, like triethylamine. So if R is CH3 and this R can be CH3 and R can be C2H5 as well. Okay, so in class 12, we will have a chapter named on it as amines chapter or nitrogen containing compounds, where you will have to judge the basicity of these amines based on the inductive effect. So in both cases, the R2NH will have the higher basicity in aqueous phase. When we will do the aqueous phase, basicity in aqueous phase, when we are going to measure or compare the basicity in aqueous phase, in both cases, R methyl and R ethyl, in both cases, it will be here. But when it is ethylamine, then we will see that the inductive effect will be much higher compared to the hydrogen bonding interaction when it will form with water. So you will see that if it is C2H5 whole 3N will have higher when R is C2H5. Okay. So it will have higher impact, higher basicity in water than its 1 degree amine. Whereas if you go for the R equals to methyl part, then you will see that CH3 whole 2 NH will have higher basicity, but it will be followed by CH3 NH2, and then CH3 whole 3 N will come in the aqueous phase, but not in the gaseous phase. In gaseous phase, R3N, then R2NH, then
এই
R.
জিনিসটা আরেকবার ফার্স্ট থেকে বোঝাতে পারবে, বেসিক নেচার অফ অ্যামাইন্স?
So basicity in aqueous phase means we have, suppose we are dealing with C2H5. You have N, you have again C2H5, okay, and you have H, one hydrogen along with a lone pair, okay, along with a lone pair. Now, when I will put this in water, in aqueous phase means it will come in water. So in water, as we all know that it is a part of Pon family, so it will possess, it will show its hydrogen bonding nature. So when you have C2H5 and C2H5 NH, so this will form a hydrogen bond with oxygen, and the lone pair on nitrogen will form the hydrogen bond with the hydrogen of water. So here you can see the two hydrogen bonds are being formed and two plus I effects are there. Okay, two hydrogen bonds and two plus I effect. That is why the 2-degree amines always exceeds all the things. But when you have 3-degree amine, C2H5N, sorry, C2H5, C2H5, and here also you will have a C2H5, and here also you will have a C2H5 along with one lone pair which will try to form a hydrogen bond with water but with three alkyl plus I effects of the ethyl groups. So here you will see that this effects plus I effect is more important, is more prominent for the ethyl group than for the methyl group. Okay, so when you compare this with here CH3, CH2, C, sorry, it will be N, H, and H with a lone pair. So here it will form OH2. Here it will form an OH2, and here it will give an OH2. So here you can see three hydrogen bond and one plus I. Three hydrogen bond and one plus I. So this is 3 degree and this is 1 degree. Okay, 3 degree, 1 degree. So in case of ethyl group, in case of the ethyl group, we will see that the plus I effect dominates over the hydrogen bonding. The plus I effect dominates over the hydrogen bonding effect, and as a result, it will have higher basicity than the 1 degree. So you will write here C2H5 whole 2 NH will have higher basicity than C2H5 whole 3 N followed by C2H5 NH2. Okay, understood? Hello, understood? So this is how you will say. But
ফার্স্টের থেকে একটু সমস্যা হলো বুঝতে।
কোন জায়গাটায়?
আর মানে বেসিসিটিটা আমরা বুঝছি কিভাবে মানে
Basicity মানে
আহ,
এবিলিটি টু অ্যাবস্ট্রাক্ট H প্লাস। বেসিসিটি আমরা কি করে বুঝি যে আমি H প্লাস কে কিভাবে নিজের কাছে নিয়ে আসবো? হাউ ক্যান আই
হ্যাঁ হ্যাঁ
basicity measure of basicity is basicity is measured on the basis of abstraction of H plus. Okay, how well I can abstract an H plus. Okay, nucleophilicity is measured that how well I can attack an electron deficient carbon center. Basicity is measured on the basis of how good, how means what is my ease of getting abstracting or taking an H plus from someone. Here the bases are doing that with water. It is taking the hydrogen from water. So who will take the hydrogen from water? The lone pair on nitrogen will first make an hydrogen bond with the water molecule, hydrogen of the water molecule, thereby extracting it from there. Understood? First, it will make an hydrogen bond.
হ্যাঁ হ্যাঁ
So this, how much, how better a nitrogen can make a hydrogen bonding with the H of water will measure its ability to become higher basic. Okay, so when you have 2 degree amine, 2 plus I effect and 2, you are seeing that you are having an hydrogen bonding effect. Okay, so when here I am drawing it again, if you have ET and ET means ethyl, and H lone pair and water here, and you get ET and H with a positive sign here, and ET means this lone pair is taking this hydrogen and leaving this OH minus out. So now this hydrogen will form a hydrogen bond with OH2 and OH2 molecule. Okay, so two hydrogen bonds formed by the same NH part and 2 plus I effects. That is the ability of this 2-degree amine to show higher basic effect, okay, or basic nature. Understood? Now is it clear?
Yes.
Now this is same for that of methylamine as well. It is for ethylamine, and same is true for methylamine. So in case of methylamine, we will see that this 2-degree methylamine is also showing its higher basicity, followed by 1-degree methylamine, because the plus I effect of methyl is less than the plus I effect of ethyl. So plus I effect of ethyl dominates over the hydrogen bonding produced by a 3-degree ethylamine, okay, or triethylamine than trimethylamine. That is why you can see that I have written here that if R is ethyl, then 2-degree amine will be higher, followed by 3-degree amine, then 1-degree amine. If it is methyl, I have written 2-degree amine will have higher basicity than 1-degree amine, and it will have higher basicity than 3-degree amine. Understood?
Yes, sir.
Sure, কোনো doubt নেই তো?
None.
Okay. বাকিদের any doubt?
No, sir.
Okay. So this is the main thing. Next, we will come our we have already discussed about electromagnetic effect. So if I ask you, if I have to tell, if I have to tell 1 or 2 points to distinguish between inductive effect and electromagnetic effect, the first thing is inductive effect is a permanent polarization, whereas the electromagnetic effect is a temporary polarization. Inductive effect is permanent polarization. Electromagnetic effect is a temporary polarization. It is just you have double bond, okay, electromagnetic effect, it is just a double bond, and in presence of any reagent it will show its polarity, okay, a positive and a negative charge. If the reagents move away from it, then again it will join and form a double bond. So this is a temporary polarization and this is a permanent polarization. The next big difference is sigma bond and pi bond. Inductive effects operates through sigma bond and electromagnetic effects operates through pi bond. So these are the main two differences between an electromagnetic effect and a inductive effect. The next thing is resonance. So we have learned about resonance, but I have to say that resonance and mesomeric effect run parallelly. Okay, means they are not so much different from each other. They are means I can say that they are of similar order. Okay, resonance and mesomeric effect are like the same. Like if I say that benzene has a conjugation and it shows resonance. So we have defined already the rules of resonance. It should be completely cyclic, okay, planar, the molecule must be completely planar. Either all the carbons should be sp2 hybridized or each atom should be resonance assisted sp2 hybridized. The third one we have already talked about, that it should have 4n plus 2 pi electron, or it should obey the 4n plus 2 pi electron rule. And the most important one is that if they have all these three, but the molecule is not conjugated. Okay, if there is a break in conjugation somewhere in the molecule, then this resonance will not happen in the molecule. Okay, so these 4 parameters are very essential. Completely first, planar, completely conjugated, all atoms must be sp2 hybridized, or at least they have some resonance assisted sp2 hybridization planarity. And fourth, that they all must obey The molecule should obey or should have 4n plus 2 pi electrons, where n is nothing but a whole number. N can be 0 also, and n can be 1, 2, 3, not a fraction. Okay, if it is fraction, then it will be anti-aromatic compound. Okay, we have discussed about that. So this is the main thing. Now, the main form of resonance is about conjugation, and conjugation is also the main driving force for our mesomeric effect. So in mesomeric effect also we will see that the same thing is happening. Okay, so you are having, you can say that there is some conjugation, there will be some electron overlapping through a sigma pi sigma state. So all these are same. So we can say that mesomeric effect and resonance effect runs parallelly, or they have similar order. Okay, they have a similar sense of reactivity and other things. So we will do, or we will write both of them in the same order. So resonance effect or resonance effect or mesomeric effect. Okay, means there is no point of learning them in a separate way. They are 99.99% alike. 1% is not alike, and that I will discuss later. So first of all, mesomeric effect is also is like the inductive effect. It is a permanent polarization. Mesomeric effect or resonance effect, both are these effects. We can say that R effect or M effect. Okay, R effect or M effect are permanent polarization. Okay, permanent polarization. They are undergoing permanent polarization. So why? Because they are not like electromeric effect. If a group comes or reagent comes in the vicinity, then I will show polarity, or else I will not show. They are not like that. They are always in their motion, and they will show their true nature, whether they're in presence of someone or in absence of someone. Okay, it doesn't bother them. Anybody's presence or absence doesn't bother them much. So this is the main thing. This is occurs via a polarization, and the polarization is permanent. Okay, this is polarization, PO. Okay, this is polarization. Polarization. This is now the next thing is this is also these groups. This effect is mainly so you can say that this effect is this effect comes in motion because of conjugation. So you need groups conjugated with a pi bond or an alternate set of pi bond along with something else, so that it can come into action. Okay, without conjugation, this distribution of electron does not occur. Okay, suppose the type of conjugation that we have read, A double bond B, C double bond D, or you can write it D and you can write it as E. Okay, to remove the barriers. Okay, the similarity C can be you can confuse it with carbon. I'm just giving an example. So here the double bonds are in conjugation, so we can easily understand that these are conjugated. Now who will show this type of effect? Who will show that I am donating electrons? So if I have electrons extra, okay, like if I have lone pairs, then after completing my octet, I have the ability to donate my electrons. If I am having, if I am a atom, okay, I am an atom, and for completing my octet, I shared electrons. For completing my octet, I shared electrons, and after sharing, if some electrons are left behind, which did not involve itself in which did not involve itself in sharing to complete my octets. They are those electrons which did not participated in bonding or in the formation of bond. In that case, those electrons will be called as other electrons, or if there is a pair of electrons, then we will call them as a pair of electron or lone pair of electron. Okay, because they are alone, so that is why they will be named as lone pairs. Okay, so the elements or atoms which have lone pairs are, they actually show this R and M effect. So the atoms which have lone pairs, they show this R effect or M effect. Okay, so you can say that plus R means electron donating effect, or plus M as electron donating effect. Who can show? Oxygen, it can be R, it can be OH, okay? Then NH2 or NR2, anything, okay? Those who have lone pairs, sulfur, halogens, okay? They have lone pairs, okay? They have lone pairs, R or H, okay? These are plus M effect. Who has minus M effect? Those who have the ability to take electrons away, okay, like if you have C double bond OH, so this will show minus, okay, because oxygen here is here, it will take the electrons from this carbon. So here if you have CH2, C a double bond CH, single bond CH, double bond O, so it will take this electron away from here, and this is conjugated. So CH2 minus plus single bond CH, double bond CH, single bond O with a minus sign. Okay, so this is how the more electronegative atom will take the electrons towards itself. So CHO group, then you can say NO2 group. Okay, NO2 group shows minus I, minus R, and minus M. I will make a list out of it and then I will discuss it with you. So these are the main things and they have high
স্যার
application.
মাইনাস এম আর মাইনাস আর এফেক্টে কি হচ্ছে?
Electron withdrawing through resonance. Minus
আচ্ছা,
electron withdrawing through resonance. Conjugated system থাকবে তখন সে
আর প্লাস এম আর প্লাস আর এ কি হচ্ছে?
electron donating via resonance. আমি electron দিচ্ছি, I am donating it.
ওকে ওকে।
Understood?